Today I want to spend a little bit of time talking about HashiCorp tools in the context of using Kubernetes. I think we often get asked across the whole portfolio of HashiCorp tools, how are they meant to be used? Are they used in conjunction with Kubernetes? Does it make sense to use them if there's some of that functionality that's already built into the Kubernetes platform? Where do the different edges and use cases of the tools belong? So I thought we'd spend a little bit of time talking across the whole HashiCorp portfolio and where the different tools sort of fit in alongside Kubernetes. So I think maybe where it makes sense to start is to think about it through the sort of life cycle of managing a Kubernetes cluster, right? So if we think about a Kubernetes cluster, it generally comes in maybe two different flavors. One flavor is sort of a cloud managed solution. So think, GKE, AKS, EKS. These are solutions where a cloud vendor is providing the Kubernetes cluster for us in sort of a fully managed configuration. So in a mode like that, one of the first problems we have is how do we actually define that cluster and stand it up, right? So oftentimes this is where Terraform is used, right? So Terraform can be used in sort of what I'll call this sort of southbound setting of Kubernetes, right? Sort of southbound in the sense that it's sort of the operator responsibility. We're setting up a Kubernetes cluster that's going to be used, let's say, by an application team or a separate team internal to the company. So on the southbound, in terms of standing up Kubernetes, we can actually go ahead and use the cloud-specific providers that Terraform has. So this could be, for example, the GCP provider, could be the AWS provider, the Azure provider, etc., which provide us a resource to define a GKE cluster or an EKS cluster or an AKS cluster, etc. So in this sense, on the southbound, we'll use it to stand up and deploy an actual Kubernetes installation. Now, another common way that Kubernetes is stood up is sort of self-managed, right? You're operating it yourself, might be on-premise with something like OpenShift. You might be using the vanilla distribution. And so in that case, you might be authoring Terraform directly, right? You're actually writing Terraform modules, or in the case of OpenShift, you're using the OpenShift installer, which leverages Terraform. And so here you're writing a Terraform module, or using one that exists already, but still using it to stand up Terraform on the sort of southbound. So great, now we have a Kubernetes cluster. The next kind of challenge is before we hand it to our application teams, there's a bunch of kind of setup we might want to do on that cluster. This might be things like defining namespaces, defining policy, defining quotas, things like that. So I'll kind of call this the kind of cluster setup, if you will, right? So we're not quite yet at deploying applications, but it's sort of that more policy level, governance type things we want to do. So at this level, we can also use the Terraform Kubernetes provider. So there's a Terraform Kubernetes provider that allows us to specify things like namespaces, quotas, different policies, etc. So we might, as an operations team, still use Terraform, using sort of maybe a module that defines how we want to configure our cluster when we stand it up, and use that to kind of set it up. Now at this point, we're sort of ready for our applications to land on the cluster. We've stood it up, we've configured it, we have the policy in place. So then when we want to define an actual workload, right? So application 1 and application 2 that's running on top of this cluster, there's a bunch of different choices of tooling that exists here, right? We might define a workload, through a YAML file and directly use the Kubernetes CLI tools like kubectl to apply and create these things, right? Defining, a deployment and the other objects we might need. It might be that this application is already packaged up as a Helm package, and so we're using Helm to deploy and install this. So there's a variety of different ways. Our philosophy really comes down to we want to capture all of this as code. So what we really don't want to do is have people directly, creating things through a UI or doing it through a CLI, and then we don't really have a source of truth, right? If we need to recreate it or rebuild it, we don't have it living as infrastructure as code to easily be able to recreate, right? So whether it lives as, a Helm configuration, whether it lives in sort of a YAML file, whether it lives in native Terraform, the idea for us is, again, with Terraform, you have multiple of these options. You can do it through the Kubernetes provider. So this would let you directly specify, a deployment object, a daemon set, a CRD, etc., much like you would model it in sort of a YAML configuration. You can also use the Helm provider. So if you're leveraging existing Helm packages, you can use that without having to refactor it out of Helm. And so it doesn't really matter either way. You can still specify a Terraform configuration that's going to use both of these providers, possibly at the same time. And you can even have this provider live in conjunction with these other resources. So for example, if I'm running on top of GKE, right, in addition to my app running on Kubernetes, maybe I have, a database that I need. And so within the same Terraform configuration, I can specify the database that I'm consuming as a managed service from Google, in addition to maybe using Helm and the Kubernetes provider to provision the application itself running on top of Kubernetes, right? So in this sense, you can see how Terraform can be used with Kubernetes in almost 3 different layers, right? There's sort of southbound operator facing. There's still like northbound, right? We're sort of on the north side at this point, but it's still operator facing instead of setup and configuration. And then all the way up, this is more developer facing in terms of how do we actually consume not only the applications that run on top of Kubernetes, but other dependencies we might have, such as a database, such as a blob store, etc. Right? So all of those can be provisioned and managed through Terraform. So this is one piece, right, in terms of how do we define the life cycle. Day 1, stand this up. Day 2, if we need to modify and evolve it over time. And then day 3, if we want to decommission it, right? Whether we're tearing down this one app, we can use Terraform. Whether we're evolving the setup or whether we're destroying the entire cluster, we can use Terraform for all of that. Now, moving, into kind of runtime, right, further down into the life cycle, the next challenge is often these applications frequently need sensitive credentials, right? So in this case, for example, how does A1, which maybe requires this database, actually get that database credential? So Kubernetes itself has a notion of secrets. The challenge is these secrets have relatively limited role-based access control around them, relatively limited audit, and in many configurations, they're actually stored at rest unencrypted, right? So, for a variety of reasons, Kubernetes secrets tends to be a little bit on the sort of weak side in terms of the guarantees we want of everything being encrypted at rest, everything encrypted in transit, tight access control, tight visibility. So it's very, very common that alongside of a Kubernetes cluster, people will leverage Vault. Vault has a number of different use cases. Most commonly, it's used as a secret manager. So if we're storing things like database credentials, certificates, API keys, those kind of things, we store them within Vault and fetch them. But Vault can also do more sophisticated things like dynamic secrets. So instead of storing a static database password or a static certificate, Vault can actually generate them on demand by integrating with the database or acting as a certificate authority. So this lets us get much more sophisticated and move to a model where we have constantly rotating ephemeral credentials rather than long-lived and static, right? In addition to that, we can use Vault to actually do data protection. So treating it as a sort of a key manager and allowing us to encrypt data, sign transactions, tokenize things, etc., and provide sort of a simple application level API. So for a number of different reasons, we might want to use Vault alongside to provide either core secrets for our applications or to act as middleware to actually protect application data. So the way this tends to work is we tie this application to a service account or a service jot, right? So we'll have a dedicated Kubernetes service account that identifies, in this case, application A1. And so when this application comes up, it can then authenticate with Vault using the JWT identity that it has. Vault then integrates back and validates, great, we know this is application 1 or this is application 2. Based on the identity of that application, we can then give it access to different credentials, right? So it might say it gets access to the database credential as well as a certificate as well as an API key. And so there's a number of ways this integration can work. We have a Vault agent, so that this can act as sort of an init process and a sidecar. So the application's generally sort of unaware. The init container does this workflow to authenticate against Vault, fetch the secrets, and put it on disk in really a memory shared segment. So the application, when it boots, it just reads its credentials from /secret, and it's sort of none the wiser that that credential came from Vault, right? So this gives us a seamless way to integrate an application without really having to know about Vault. It just boots and reads its credentials like normal, and great, those things happen to be getting sourced from Vault. Now, if the application is slightly more sophisticated and it wants to directly leverage the Vault API to do data encryption or tokenization or things like that, then once it's been authenticated through that Vault agent and the sidecar, it has a Vault token already available to it. So it can use that token to directly query Vault and use its API and do things like data encryption and tokenization, right? So it gives us multiple options for a simple use case where we don't want our application to have to be aware of Vault and have to modify all of our applications. We can use the Vault agent and have sort of a transparent workflow. In the other cases where we want the more advanced capabilities, we can still use the agent to do the base secrets and then leverage, Vault API and SDK to get more sophisticated, right? So this tends to be how Vault fits into the picture. Now the next piece tends to be Consul, right? And I think this is really about service networking and then service mesh. So you might say, great, if I'm within Kubernetes already, why do I need a service networking or a service discovery solution, right? I already have it built in. Kubernetes has a notion of being able to do label-based selectors, and I can do the discovery, and I have DNS within my cluster. And that's often true. If my use case is only service discovery within a single Kubernetes cluster, I probably would be satisfied just with the primitives that are available. I think the areas where it starts to become more sort of relevant, where we see Consul get frequently used, is what happens when I'm now spanning multiple Kubernetes clusters, right? So I might have multiple because each of my app teams has a different cluster. So this is app team A, and I have a different app team B, right? And they have their own cluster. So their workloads are separate, right? And so now maybe I have application A1 needs to be able to reach B1, right? And so now I'm crossing the barrier of a Kubernetes cluster, and that doesn't really work particularly well out of the box, right? So this is one classic example. Maybe it's because there's different teams. It might be a scale thing, right? Tends to be that the Kubernetes clusters work better on the smaller side. So if I have a very large application, I'm sharding my workload across multiple different Kubernetes clusters. Could be that this is east and this is west, or cloud and on-prem, number of different reasons here. But in this scenario, what we often end up seeing is that then you can treat Consul as sort of a common discovery layer across all of this, right? So all of these clusters get bridged in so that Consul has sort of a bird's eye view of what are all of these different services that are available across it. And so the first thing this enables is sort of a cross-cluster service discovery, right? If I'm A2 and I need to discover B1, I can query it and do that service discovery and then connect to this instance across in a different Kubernetes cluster, right? So this is level one in what you might consider sort of that service discovery use case. Now as we go one level deeper and talk about service mesh, I think what that starts to bring in is how do I do traffic authorization between all of this, right? Service mesh has a number of different, sophisticated use cases. It's everything from routing, right? If I want to get fancy in terms of saying, great, when traffic comes in, I want 90% to go to version 1 and 10% to go to version 2. So I can do that sort of traffic management. But then from a security aspect, it also gives me the ability to say, great, A2 is allowed to talk to B1. A2 might not be allowed to talk to B2, right? So I can express those more granular policies in terms of what services are allowed to talk to one another, and the mesh will enforce that. So Consul can act as a service mesh that spans not only multiple Kubernetes clusters, but as well other non-Kubernetes workloads. So if I also have a set of VM-based applications, right, that need to interface with, Kubernetes-based applications, Consul can provide a way of spanning all of that, right? So we can start and just use it for doing the discovery where we're just routing, and then we can go incrementally and add the service mesh capability to get the more sophisticated traffic routing, security, observability, etc. Right? So stepping back of the kind of common core HashiCorp portfolio, you can see how Terraform is used throughout the life cycle, right? Everything from stand-up and configuration to application deployment. Vault can be used as a secret management solution, as well as to provide a way for applications to do their data protection. And then Consul can act as a powerful service networking tool when you're spanning multiple Kubernetes clusters, cloud and on-prem, multiple regions, etc. It adds additional richness not only in service discovery, but as well in service mesh. Hopefully that gives you a sense of how the HashiCorp tools can be used within the Kubernetes ecosystem. Thanks.